Okay, so here is the proof as promised of example 7 from in class. I'm going to start with the right-hand side because that one looks more complicated to me. So we'll start with sine squared x minus 2 times sine to the 4th x plus sine to the 6th x times cosine of x, which is my right-hand side. My next movement is going to be to factor out this front factor. So I'm going to take out the GCF, which is a sine squared x, leaving me 1 minus 2 times sine squared x plus sine to the 4th x times cosine of x by factoring. And then I'm going to go ahead and factor this here. So I'm looking, this is a squared to the 4th, so it looks like it's quadratic in form, and then I can recognize this as a perfect square trinomial. So I have sine squared x times 1 minus sine squared x squared times cosine of x, factoring a perfect square trinomial. And then I'm going to look and say, hey, 1 minus sine squared x, that is a Pythagorean identity. I start with sine squared plus cosine squared equals 1, subtract sine squared from both sides. So this equals cosine squared. So sine squared x times cosine squared x times cosine of x, and that is Pythagorean identity number 1. And then here I have cosine, I forgot my little squared. So I have cosine squared squared, which is sine squared x times cosine to the 4th x times cosine of x, and that's power rules or multiplication if you prefer that way. And now I have cosine to the 4th times cosine, so I have sine squared x. I'm going to write it without parentheses because I want it without parentheses, times cosine to the 5th x, and that is, again, power rules, and that is my left-hand side, so I'm done. So as you can see, this is a very doable proof, but it did require recognizing that perfect square trinomial and then recalling our power rules, which we didn't review. So you have all the information that you need in order to do this proof, but it's not quite the level that I expect you to be at yet.